Today is a review of Algebra 1, Lesson 3-7. Slope of a line is the ratio of the vertical change to the horizontal change, rise over run. So when you calculate slope, you try to find your rise, which is your change in your y, and your run, which is your change in your x. So let's practice a few of these. So here are some graphs. So when we're doing graphs, we're just counting boxes. So my rise is down 1, 2, and my run is forward 1, 2, 3. So my slope is negative 2/3. We always read graphs from left to right. Number 2, again, here's a spot. Our rise is up 1. And my run is 1, 2, 3, 4. So life is good when we have a graph and we can count our squares. Let's try some examples with points. So remember, here is our formula for slope, change in y over change in x. So I'm going to use this as my first set of points, and this is my second set of points. So I'm going to go negative 6 minus 3 over negative 1 minus 2. So I get negative 9 over negative 3, which reduces to 3. If I change my order, which would mean changing these points to the second one and these ones to the first ones, then I get 3 minus a minus 6 and 2 minus a minus 1. And minus a minus turns into plus. So we still get the exact same answer depending on which point you pick for your first one, which point you pick for your second one. So why don't you try number 4 and number 5. Pause the video until you're ready for the answer. So in number 4, I went negative 2 minus a minus 6, negative 6 minus a minus 3, so I get negative 4/3. And in number 5, I went 9 minus a negative 7 and 2 minus 4 for negative 8. So here's some stuff that you need to remember. We always have positive slope when we're increasing from left to right, negative slope when we're decreasing from left to right. It's zero slope if it's horizontal, and it's undefined slope if it's vertical. So I always say if you're skiing. So if I ski, I would be cross-country skiing, so my slope is 0. If I were skiing over here, I wouldn't be having too much luck. Okay, so then I would say that my slope is undefined. So if I were to look at the equation of this line, this is a horizontal line, so the equation for this one would be something like y equals 4, and the equation over here would be something like x equals 7, just depending what your scale is. So if it's in a y equals equation, the slope is going to be 0, or if it's an x equals equation, then it's going to be undefined. Then we get into slope-intercept form, y equals mx plus b, where m is your slope and b is your y-intercept. Also in Algebra 1, you learned about point-slope form, y minus y sub 1 equals m times x minus x sub 1. So for point-slope form, you just need a point and a slope. And for slope-intercept form, you need slope and an intercept. So let's try this. Number 6, it says to graph. So if we compare this to y equals mx plus b, our m is 3, and our b is negative 4. So if I were to graph this, I want to do my y-intercept first, 1, 2, 3, 4, and then if I apply my, so 3 is my slope, so that's 3 over 1, so that means up 3, forward 1, up 3, forward 1. Otherwise, if I do the opposite of that, negative 3 over negative 1 still reduces to 3, so I could count down 3 and backwards 1, but that one's off my graph. So there's my graph. In the second one, we're written in point-slope form. So my m is a 1, which is the same thing as rise 1, run 1, or negative 1 over negative 1. And then the point, notice how the formula shows minus x sub 1. So this is really x minus a minus 3. And then the 2 is positive. So our coordinate is negative 3, positive 2. So So when I start graphing, I go to -3, +2, and I can go up 1, forward, up, forward, up, forward, or I can go down, back, down, back. And there's the equation of my line. Why don't you try number 8 on your own? So I notice that my slope is 4, so that gives me -4 over 1, or 4 over -1. So it doesn't matter if the negative is on top or on the bottom. Then I'm looking for my coordinate. So I get a -3 and a -2 for my point. So that's where I start on the graph, and then I can apply my slope. Down 4, forward 1. Or I could go up 4, backwards 1. Here's one of the other skills we need to remember from Algebra 1. Use the given information to write an equation for each line. So number 9, m is 6, and our y-intercept is 4. So we're just writing in y equals mx plus b. So we get y equals 6x plus 4. Number 10, same idea. Y equals -1/3 x minus 2. In 11 and 12, we have to pull that information off of our graph. So I'm looking for my slope, so I'm rising up 2, forward 3. So that's 2/3. So if I apply that again, down 2, backwards 3, I end up here. So I can't look at my graph and anticipate my y-intercept. So I'm going to start out in point slope form instead. So I'm going to use the 1, 2. So I have y minus y1 equals m times x minus x1. So I get y minus 1, y minus 2, because 2 is our y value, equals 2/3 times x minus 1. Because remember, 1 is our x sub 1 and 2 is our y sub 1. So that's the formula we get. So now we're just distributing. And now I need to add 2. So we get y equals 2/3 x plus 7/3. Try number 12 on your own. I'll pause the video. This graph is a little bit easier than the previous one. If I go down 6, forward 4, I get from point to point, so that's my slope, which reduces to -3/2. So if I apply that, down 3, forward 2, notice how I hit that graph. So that's going to be my b value. On the previous equation, we did not hit the graph when we went down to backwards 3. We didn't hit that y-intercept, so we had to do something different. Where in this one, this is a little more basic. So we get y equals -3/2 x plus 2. Another skill from Algebra 1 that you had to be good at was using information to write an equation from a line, so given 2 points. So when we write lines, we do y equals mx plus b, so we have to figure out what m is, and we have to figure out what b is. So the first thing we want to do is calculate the slope. 10 minus 0, 3 minus a minus 2. So we get 10 over 5, which is 2. And now we're going to pick a point, and I'll just pick the first one. So we're going to do point slope form. And we get y minus 0 equals 2 times x minus a minus 2. So this is my x sub 1, and this is my y sub 1. So I am going to distribute, and y minus 0 is just y. Try number 14 on your own. Please pause the video. Here's the solution to number 14. 1/2 is my slope. I picked the first point just so I didn't have to deal with any negatives. plug and chug, and I get y equals 1/2 x minus 3. If you want to on these questions, you could have used slope-intercept form also. Instead of using point-slope form, it just is a little bit lengthier. You still get your value of 4 and you still get your value of -3. You pick your method. Let's review horizontal and vertical lines. Graph each line, y equals -4. So here's my y-axis, 1, 2, 3, 4. So that's where y is equal to -4. If we were to make a table, we're trying to graph a line where every y value is -4. So if I plug in 1, if I plug in 2, if I plug in 3, so then these would be the coordinates that fit. So here's the graph that we're looking for, where every coordinate on that line is going to have a y value of -4. In number 16, if we were to make a table, we want every x value to be 3. So then if we plug in some numbers, the points would fall on our line like below, and our graph would look like the green line. To review slope, what is the slope of the red line? Think cross-country skiing. Can you cross-country ski on it? Yes, so the slope is 0. What about the green line? Can you cross-country ski on it? No, you would die or get hurt, so that one is undefined. Try number 17 on your own. Pause the video, please. Here's the solution. Our slope would also be 0 again. On this slide it says write each equation in slope-intercept form. So we need to distribute and get y by itself. So in the first one, what we can do first is distribute our 4. And we have y minus 3 equals 4x plus 8. And then we're just going to add 3. Try the next two problems. Pause the video until you're ready for the answer. Here are the solutions. This concludes my video.